Hi, this is Dr. V.S. Nishok from EC Department, SNS College of Technology. In our previous videos, we have seen about the operating point and bias stability of the BJT transistor. In this video, as a continuation of it, we are going to see the simplest biasing technique called fixed bias configuration of BJT transistor. So, these are the topics that we are going to discuss in this video. Why does a transistor need biasing? So let us have a question whether the transistor automatically amplifies the signal. So for this question the answer is no. So we need to provide the proper operating condition so that we can the transistor can amplify the given signal and produce the expected output. So this requires the proper operating point. So that is our biasing. So by proper biasing, the operating point of the transistor is fixed at the active region and it provides the proper faithful amplification. So the example are many electronic systems like audio amplifiers, communication circuits and sensor amplifiers. So everywhere the biasing is necessary. So here when the transistor goes to the wrong operating condition, we know already that the output will be distorted and the information will be lost and poor amplification will be done. So which results in the signal clipping, etc. So that we are coming to the clarity that we need proper biasing. So here we can see the biasing is provided by the base current IB through the DC supply to the transistor. So that is the current from the supply, DC supply, we are providing it to the base terminal of the BJT transistor. So it will establish the proper operating point. So this enables the proper transistor operation. So this fixed bias configuration is the simplest biasing technique. So now let us see what is fixed bias. So the base, so if you are from the DC source, a resistor is connected to the base of the BJT transistor. So when the DC voltage is applied, so it creates the base current across the base terminal of the transistor, which controls the collector current. So this base current that applied across the base terminal, which controls the collector current, so that by controlling the collector current, we are creating the proper Q point in the active region. So coming to the working principle of fixed bias configuration. So when the base current flows, the collector current is produced, which is effectively makes the transistor to operate in the active region so that the amplification become a faithful one. So coming to the limitations of the fixed bias. So here even though this circuit is very simple, it provides the poor stability since when the temperature varies, when we are using this transistor for any applications for a long time of use, the temperature changes may affect, increase in temperature affects the transistor operation and transistor characteristics, which may shift to the Q point and leads to the distortion. So that this is not widely used in practical circuits. So coming for the practical applications. So because of its poor stable operation, this is mainly used in educational laboratories and basic transistor circuits and learning the transistor operations in academic experiments. So let's summarize. Fixed bias with its poor biasing stability, so we can use this for a study purpose, which is mainly, so this type of biasing is mainly used for making the transistor to operate in the active region. So let us check our understanding. The main purpose of biasing is amplification setup, and the fixed bias suffers from poor stability. So these are the reference books and websites we have utilized for our video. So even though this type of fixed bias configuration have the poor stability, so this leads to the improved biasing techniques that we can see in the next videos. Thank you all for joining the video. You can join in the next video.